Now, did everybody draw the drawings?
Not yet.
All right, so everybody, I want you to get the drawings there. And I want you to also remember how we measure mass, or the amount of matter, is we have to use one of these 4 tools, okay? And in science, these are some of our tools. All right? Everybody got them?
No.
You got them all?
Dude, do you have glasses?
You got the other 2? Get the other 2. So you got the measuring cup, graduated cylinder, don't forget the beaker, and the balance scale. All right. Now, does anybody have any of these at home?
No.
Mom and Dad use these? What do you got?
I have it
Do you have any? Which one?
on the blue coin.
Which one?
Not the blue coin.
Oh, the blue kind. Okay, so now, what is Mom is cooking? Does she use anything up here?
Measuring cup.
A measuring cup, right? So we use this to measure liquids, to measure sugar, to measure powders, things like that. Because you can't just pour any old amount that you want, right? Let's say you're baking a cake, and it says you need to have 1 pound of sugar, and you put 5. What's going to happen to the cake? Cake is not going to taste good, right? So the reason we have measuring cups, beakers, graduated cylinders, balance scales, is because everything has a certain amount of matter that needs to be added, okay? When you have a bowl of cereal, right, you pour the cereal in the bowl. Can you just pour as much milk as you want into that bowl?
No.
What's going to happen if you keep pouring the milk? It's going to what?
Overflow.
Overflow, okay? And that's the idea. So even the things that we take for granted, like pouring a cup of cereal, or what about a glass of water?
That's too much water.
If you put too much water in the cup, right, and you go like this, if you start shaking it, what's going to happen? The water's going to what? Spill over, right? So the same idea. A lot of these things that we use are to keep us focused on what we're trying to figure out, all right? Now the next word that we have is volume. How much space an object takes up. Now we're trying to figure out what volume is and how we measure that. So write that definition down. Volume is how much space an object takes up. And these are the 3 words: matter, mass, and volume. They're like the 3 musketeers. You can't have one without the other. Matter, mass, and volume.
No.
Anybody got any questions so far just about the vocabulary before we really start talking about what this all means?
No.
Anybody confused about anything?
No.
Okay, so now,
You learned that.
here's matter, here's mass, here's volume. What's the key word in this definition? What's the word that stands out? Everything? Not necessarily space. Who said it? He said anything, right? Yeah, so matter is anything. Okay, that's the key word. What's the key word in mass?
Measure?
Okay.
Measure, yes. What's the key word in volume?
How much?
That's 2 words.
Space?
Space. Very good. So now, on your notes, I want you to circle these words,
Lower than.
okay? Because those are key words that you might see on a test. Now the idea is, let's say you forget it, and you're not really familiar with the stuff. At the end of the day, you know matter could be anything. Okay, you know when you're talking about mass, you're measuring something. And then when you're talking about volume, you're talking about the amount of space it takes up. Has anybody ever taken a bath?
Yeah.
How do people take baths? Okay, who fills up the bathtub for you? You fill it for yourself? So Mom and Dad. Now there was one time when I took a bath, right? I let the water run, and it was like about, let's say this is my bathtub. Okay, let's say it's a bathtub, all right? I put the water like this on. Now, the bathtub's pretty full, right? You say it's about 75% full. Now, it was nice and warm, I had Mr. Bubbles, I was ready to go, I had my Angry Birds, I was going crazy. Alright, because I'm a big Angry Birds fan. Now, I weigh 240 pounds. Okay? So, if I'm looking at matter, am I a lot of matter? Yeah.
Yes.
As far as my mass, how much do I weigh? I weigh 240 pounds. But my volume, when I'm thinking about my volume and how much space I take up, I was about to find out right now when I jumped inside the bathtub. When I jumped inside the bathtub, and I literally jumped in, I ran and I jumped in. The idea was what? As I get into the water, right? The water has to what?
Go up.
It has to go up because it has to account for what? My matter or my mass, right? So as I get into the water, what does the water start to do? Rise up because it displaces me, right? Well, let me tell you what happened. I jumped into the bathtub, and as soon as I got up, the whole thing went, and then the water leveled out. So the idea is, if you wanted to measure, right, my volume, and let's say we fill the bathtub to the top, 100%,
Wow.
and then I get in, and then all that water gets displaced, and we subtract what the water was from the amount of water that came out, then I know what my volume is, right? But the idea is, when you get into the, like, how much do you weigh? You probably weigh like 65 pounds, right? Something like that, 70 pounds? So if I throw you in a giant pool that's 12 feet deep, right?
Wow.
Are you going to displace the water?
No.
No, right? Because I'm going to throw you in, it's going to suck you right in, no problem. If I take like 100 people, and on the count of three, I say 1, 2, 3, cannonball, right? Everybody jumps into the pool. The water's going to go out, right? Because it's got to make space for all those people, yeah. So that's what we're trying to look at. When we're thinking about science, you've got to put it into practical terms. All right, now if you want to do this experiment, this is what you do. All you do is you get a bowl or a cup, like, you know, a drinking cup, and you fill it to the top. And then you just take your hand and you stick it in the cup. Okay, and what's going to happen is the water's going to go right out, okay? That's the idea. Or you could ask your parents to fill the bathtub for you, all right? And basically, I wouldn't jump into the bathtub, but the idea is you get into the bathtub and you mark a line where the water is in the bathtub, right? So the bathtub stops. And then you get in and you see if the water line goes up or it goes down. And that's the way to experiment. Can you do that in school? Can you bring that experiment to school? No. Because you don't want to take a bath in front of anybody. But that's what we're talking about. All right. Anybody else have any examples of where they displace water or something happened to matter? What happens if you put something in a microwave, right, and you add heat?
Explode.
And it says only microwave for 1 minute, but you do 20.
Oh.
Kaboom.
Explodes.
It could explode or it could melt. Anybody pop popcorn?
Yeah.
Okay, you ever pop popcorn in the microwave?
Takes like 3 minutes or
Yeah,
not.
so the bag says like it takes 3 minutes, but a lot of times you put it for like 4 minutes. What happens if you let this stay for 10 minutes? What happens to the popcorn or what?
Everything will go
It burns, right? Because that matter is affected by the energy. So what we're learning too is that depending on the type of matter it is, if we introduce another element, like heat, like water, like cold, they can change the physical chemicals in the matter. Now, everybody has this? Okay, now let's go to the next thing. So now,